Good morning to one and all. I am DR.S.THAIYALNAYAKI, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Now we see about the data science using Python for first time as a computer science students. This is a core paper. Already we see about the Python, installation of Python, etc. Now we see about the why we use Python for data analysis and data structure and sequence in Python. These concepts are we are discussed below. First one is Python language. In every language we use data. Then what is meant by data? Data is nothing but an essential part of any enterprise or business. It is critical to collect, process and analyze data flow in a timely and accurate manner to discover information useful for decision making in business. Next one is data science. The data science industry is rapidly expanding. Data volume can be large, making information handling difficult and time consuming. Next, Python language. Python is a popular programming language in a scientific computing because it has many data-oriented feature packages that can speed up and simplify data processing, thus saving time. What is meant by Python? Python is an object-oriented, high-level programming language. It's built in data structures and properties combined with dynamic typing. That means we don't have to declare the type of variable like C or Java. And binding make it ideal for application development and its use as a scripting language. Python is a simple syntax emphasize readability and reduce programming maintenance. Python is a programming language that can be used for a wide range of tasks such as software creation, web development, script writing, unlike HTML, CSS and JavaScript. What is data analysis? Data analysis is the process of gathering raw data and converting it into information that the users can use to make decisions. It entails inspecting, cleansing, transforming and modeling data to uncover valuable information, draw conclusions and aid decision making. In today's business world, data analysis plays an important role in making scientific decisions and assisting business in operating more efficiently. Data mining is a form of data analysis technique that emphasizes statistical modeling and information exploration for predictive rather than strictly descriptive purposes. Business intelligence encompasses data analysis that is heavily reliant on aggregation, focusing primarily on business information and decision making to boost profit turnover. Next, what makes Python a brilliant choice for data analysis? Python is a multifunctional, maximally interpreted programming language with several advantages that are often used to streamline massive and complex data sets. Python has a number of distinguishing characteristics that make it the best option for data analysis. See the features of Python. First one is easy to learn. Python focuses on both simplicity and readability, while also providing a plethora of useful options for data analysis scientists. As a result, even novices can easily use a relatively simple syntax to create effective solutions for complex scenarios with just a few lines of code. Second one is it's a open source. Python is an open source, which means it's free and uses a community-based model for development. Python is designed to run on Windows and Linux environments. It can easily be ported to multiple platforms. There are many open source Python libraries such as data manipulation, data visualization, statistics, mathematics, machine learning and natural language processing. To name just a few, here see the few Python libraries. Next, the third one is it's a well supported one. Anything that can go wrong will go wrong. And if you are using something that you did not need to pay for, getting help can be quite a challenge. Fortunately, Python has a large following and is heavily used in academic and industrial circles, which means that there are plenty of useful analytics libraries available. Python users needing help can always turn to Stack Overflow, mailing list, and user contributed code and documentation. And the more popular Python becomes, the more users will contribute information on their user experience. and that means more support materials is available at no cost. This creates a self-perpetuating spiral of acceptance by a growing number of data analysts and data scientists. No wonder Python's popularity is increasing. And fourth one is flexibility. Python's extreme versatility is another powerful attribute that makes it popular among data scientists and analysts. As a result, data models can be created, data sets can be systematized, ML-powered algorithms can be developed, web services can be developed, and data mining can be used to complete various tasks in a short amount of time. And last one is huge libraries collection. It has many completely free libraries that are open to the public. That is a key factor that makes Python essential for data analysis and in data science as well. Users who work in the field of data science are probably familiar with names like Panda, SciPy, statistics, stat models, and other libraries that are widely used in the data science community. It's worth noting that the libraries are constantly expanding, providing robust solutions. And another features of Python is graphics and visualization. Visual information is well known for being much easier to comprehend, work, and recall. Python provides users with a plethora of different visualization options. As a consequence, it's a must-have a method for all data science, not just data processing. By developing numerous charts and graphics, as well as web-ready interactive plots, data analysts can make data more available. Next one is built-in data analytics tools. Python's built-in data analytics tools make it a perfect tool for processing complex data. Python's built-in analytics tools can also easily penetrate patterns, correlate information in extensive sets, and provide better insights in addition to other critical matrices in evaluating performance. There is a host of prominent programming languages to utilize for data reduction. C, C++, R, Java, JavaScript, and Python are a few among them. Each one offers unique features, options, and tools that suit the different demands depending upon your needs. Some are better than others for specific industry needs. For example, one industry survey states Python has established itself as a leading choice for developing fintech software and other application areas. There are two main factors that make Python a widely used programming language in scientific computing in particular. First one is the stunning ecosystem, and second one is a great number of data-oriented feature packages that can speed up and simplify data processing, making it time-saving. In addition to that, Python is initially utilized for actualizing data analysis. It is among those languages that are being developed on an ongoing basis. Thereby, Python is called the topmost language in a high potential in the data science field, more than the other programming languages. Okay, these are all the features of Python. Next one is data analysis. It's one of the technique to collect, transform, and organize data to make future predictions and make informed data-driven decisions. It also helps to find possible solutions for a business problem. There are 6 steps for data analysis. They are ask or specify data requirements. Second one is prepare or collect data. And third one is clean and process. And fourth one is analyze. Fifth one is share. And last one, sixth one is act or report. These are all the database data analysis steps. Each step has its own process and tools to make overall conclusions based on the data. Next, Python offers programmers the advantage of using fewer lines of code to accomplish tasks than one needs when using older languages. Is Python necessary for data analysis? We have one of the question in our mind. One of the most important skills for a data analyst is proficiency in a programming language. Data analysts use SQL, that is a structured query language, to communicate with the database, but when it comes to cleaning, manipulating, analyzing, and visualizing data, you are looking at either Python or R language. So Python is considered a more efficient data analysis tool for complex calculations and large volumes of data. Next, why Python is best for data visualization? Python offers several plotting libraries, namely Matplotlib, Seaborn, and many other such data visualization packages with the different features for creating informative, customized, and appealing plots to present data in the most simple and effective way. Next, what Python skills are required for data analysis? Which skills you need? The following are some of the important skills to possess which will come handy when performing data analysis using Python. Good understanding of the built-in data types, especially lists, dictionaries, tuples, and sets. Mastery of n-dimensional NAPI arrays. Mastery of pandas data frames. These are all the skills required in Python for data analysis. Next, what are the advantages of Python? Why we prefer Python? Over 1,25,000 third-party Python libraries exist that enable you to use Python for machine learning, web processing, and even biology. Also, it's a data-focused libraries like Pandas, NAPI, and Matplotlib make it very capable of processing, manipulating, and visualizing data, which is why it's favored in data analysis. Okay, these are all the why we use Python for data analysis. Next, we see the another concept, data structure and sequence. We will discuss the data structures in a Python programming language and how they are related to some specific Python data types. We will discuss all the built-in data structures like lists, tuples, dictionaries, etc. as well as some advanced data structures like trees, graphs, etc. Okay, now here we see about the data structure. Data structures are a way of organizing data so that it can be accessed more efficiently depending upon the situation. Data structures are fundamentals of any programming language around which a program is built. Python helps to learn the fundamental of these data structures in a simpler way as compared to other programming languages. Here Python has several built-in data structures. First one is list. List is nothing but a collection of ordered elements. It's a mutable one and it can contain elements of different types. And second one is tuple. Tuple is nothing but it's a collection of ordered elements, but it's a immutable and can contain elements of different types. And third one is dictionary. It's an unordered collection of key value pairs. It's a mutable one. And the fourth one is set. It's an unordered collection of unique elements. It's also a mutable one. And then fifth one is string. It's a sequence of characters, but it is a immutable one. And last one, sixth one is range. It's a sequence of numbers. It's a immutable one. Additionally, there are also advanced data structures such as arrays, linked list, stack, queue, tree, graph, etc., which can be implemented using Python classes and data structures. Here we see the elaborate list. Python lists are just like arrays declared in other languages, which is an ordered collection of data. It is very flexible as the items in a list do not need to be of the same type. The implementation of Python list is similar to vectors in C++ or array list in Java. The costly operation is inserting or deleting the element from the beginning of the list, as all the elements are needed to be shifted. Insertion and deletion at the end of the list can also become costly in case where the pre-allocated memory becomes full. We can create a list in Python as shown below. Here we see the example for Python list. Here we create a Python list. List have 1, 2, 3 and some characters GFG and 2.3 values, some values. It's stored in list. Next we see the print list. Output we see for output. Output here we see that list elements can be accessed by the assigned index. In Python, starting index of the list sequence is 0 and the ending index is n-1. If n elements are there, we have a n-1 is the ending index. Next, second type is dictionary. Python dictionary is like a hash table in any other language with the time complexity of O of 1. It is an unordered collection of data values used to store data values like a map, which unlike other data types that hold only a single value as an element. Dictionary hold the key value pair. Key value is provided in the dictionary to make it more optimized. Indexing of Python dictionary is done with the help of keys. These are of any hashable type, that is an object whose can never change like strings, numbers, tuples, etc. We can create a dictionary by using curly braces or dictionary comprehension. Here we see some of the examples for dictionary. First of all, we create a dictionary. DICT is the name for dictionary. Here name we assign the value A.D.M. College. For 1 we assign the values 1, 2, 3, 4. Next print creating dictionary. Print DICT, that is a dictionary name. We see the output. And next one is accessing a element using key. Here print DICT of name. Name is nothing but the index name. So we have the A.D.M. College as see the output. And another one is accessing element using get method. In this get method we use print DICT dot get of 1. That means we have in one index we have what value we have 1, 2, 3, 4. We said that the output. And the next one is creation using dictionary comprehension. Here my DICT is the name of the dictionary. Here in X, name of the X, we have a value X power 2 for X in 1, 2, 3, 4, 5. Then we see the output by using print statement, print of my DICT, my dictionary. In output we see that 1 is to 1, 2 is to 4. In output we see that like that 3 is to 9. That means 3 power 2, 9. Next 4 power 2, 16. 4 is to 16. And the last one 5 is to 25. 5 power to 25. Here we see that output. These are the examples for dictionaries. Next tuple. Python tuple is a collection of Python objects. Much like a list, but tuples are immutable in nature. That is, the elements in the tuple cannot be added or removed once created. Just like a list, a tuple can also contain elements of various types. In Python, tuples are created by placing a sequence of values separated by comma with or without the use of parentheses for grouping of the data sequence. Here we note that tuples can also be created with a single element, but it is a bit tricky. Having one element in the parenthesis is not sufficient. There must be a trailing comma to make it a tuple. Here we say some of the examples for tuple operations in Python using Python. First, creating a tuple with the strings. Here we assign the name tuple equal to within parenthesis single quote A.D.M. College comma single quote farm. Print tuple. We see that output as the A.D.M. College farm. Next, we create a tuple with the use of list. Here, list 1, we use a square bracket, some numbers 1, 2, 4, 5, 6, some numbers. Here, print that tuple using list. Tuple of list 1. We see the output. Next, accessing element using indexing. Print first element of tuple. Print tuple of 0. That means in index 0, what is the output? It will be display for our output. Next, accessing element from last, negative indexing. That means print of tuple of -1. It means last index. Accessing element from last. And then last element of tuples, third last element of tuples. From that, it will be count from last to first. So, print of tuple of -3. Next one is set. A set in Python is a collection of unique elements. It is an unordered, mutable and supports operations like union, intersection and difference, etc. Here is an example of how you can use sets in Python. First of all, example, creating a set. Here we have a value S. In that S value, set values 1, 2, 3. Print S means we see that output just like a 1, 2, 3. Next, adding element to the set. It means we use the add method S dot or add of 4. Print S means in that output we see that last element will be added for 4. Removing elements from the set. We use remove method S dot remove of 1. That is in index 1 what will we have? It will be removed. Next, union of sets. Union of sets, more than one sets will be a union. We have union it. So we use the list S1 and S2. In S1 we have a sum of the list and S2 have sum of the list. In S1 we have the numbers 1, 2, 3. In S2 we have a number 3, 4, 5. S3 equal to, we use the union method. So S1 dot union of S2. Next, print S3 means we see that output. We combine S1 and S2. We see that all values 1, 2, 3, 4, 5. Next one is the intersection of sets. In this also we use two lists S1 and S2. S1 have some values, S2 have another some values. Here we intersect both lists S1 and S2 by using intersection method. So S3 equal to S1 dot intersection of S2. Print S3 means output 2, 3. Intersection means common. In S1 and S2 we have a common numbers 2 and 3. That will be output. Next method is difference of set. Difference, yes, here also we have a two list S1 and S2. In S3 you use difference method S1 dot difference of S2. Next print S3, output we see the 1. Next another one is string. String is a Python is a sequence of characters. Strings are immutable, meaning that once a string is created, it cannot be modified. Here is an example how you can use strings in Python. First of all, creating a string by using, we have a S value. In that S, we have a value hello world. Accessing elements of a string. How will you access it? Example, print of S of 0. 0 means index. In index of 0, what is the value? H. So output we said that H. Next, concatenating string. Concatenating means join it. So S1 has some values hello, S2 have another value world. Now we concatenate it by using S3 equal to S1 plus double quote comma plus S2 plus exclamation mark. Print S3 means here we see that output hello world. Next, slicing string. Slicing means it will be cut. Print S of 7:12. Output we see the world. Next, we find out length of string. Print a length of length means LEN. Length of string S. You see that output 13. Replacing parts of a string. Here we use the replace method. S equal to S dot replace. In double quote we put hello comma hi. In that, with that replace, instead of hello, output we see that hi comma world. Next one is checking if a string contains a substring. Next, print hello single double quote in S. Output will be false. Print hi in S. Output will be true. So these are just a few of operations that can be performed on strings in Python. There are many other string operations such as upper method, lower method, split method, etc. that you can use to manipulate strings in your code. Another one is range. The range function in Python generates a sequence of numbers starting from 0 by default and increment by 1 by default and stops before a specified number. The range object is an immutable, efficient sequence type. Here is an example of how you can use ranges in Python. Here we see some of the examples for range. Using range to generate a sequence of numbers r equal to range of 5. Print list of r. Output we have the 0, 1, 2, 3, 4. Range means 0 to 4. It starts from 0. So 5 values. Next, specify the start and stop values. For example, r equal to range of 3, 7. That means we starts from 3 number and end with 7 number. So print list of r. Output we see that 3, 4, 5, 6. Next, specify the start and stop and step values. R equal to range of 2, 10, 2. That means up to start from 2, end with 10. It will be steps values are 2. So in the output we see that 2, 4, 6, 8. Note that the range object is not a list, but it can be converted to a list using the list method function. Also keep in mind that the range function generates numbers up to but not including the stop value. Thank you.